Hello. A few months ago I recorded a video where I showed you how to sign Bitcoin transactions offline, without using a hardware wallet. This setup was pretty basic, but still, I relied on 3 pieces of software: Bitcoin Core, Electrum Wallet, and Electrum S. Today I am going to show you how to accomplish offline signing, running Bitcoin Core only. The rationale for doing this, of course, is to minimize trust. When dealing with Bitcoin, the least amount of software you run, the better. This ethos alone won't keep you safe if you don't follow additional best security practices at all times. So please be very methodical following every step. And please watch my first offline signing video, if you want to know why this kind of setup is probably not right for you. Go along with this, only if you know exactly what you are doing. Otherwise, use a cold card. To start following this guide, you need to have a synced Bitcoin full node on a freshly installed Linux desktop OS, like Ubuntu, or Linux Mint. You will also need a brand new USB drive, with Linux tails flashed into it. There are links in the description section below, where you can see me set up a Bitcoin full node, running over Tor, and I2P. You can also learn how to securely create a bootable Linux Tails USB drive. Please, make sure you do everything correctly before moving on. So here's a quick summary of what we're doing today. In part 1, I will prepare the Tails USB drive, for its role as signing device. I will boot from my online PC, enable the persistent storage, and download and verify Bitcoin Core. In part 2, I will boot Tails from an air-gapped computer. A computer without a hard drive, a Wi-Fi card, nor a Bluetooth card. A computer that will never, ever, be connected to the internet. No electronic device that enters this square, can get out again. Meaning, that the devices inside it must interact, only with each other. The only way out for any one device that you brought in, is its physical destruction. If you cannot manage this, please stop right now, and use a hardware wallet. So, first thing I'll do, is to change the password that unlocks the persistent storage. Then I'll run Bitcoin Core. Create a wallet. And store it in my Tails USB drive. In part 3, I will create backups of my wallet. Industrial SD cards are ideal for securely storing data for long periods of time. I will also encode my master private key into QR codes. In part 4, I will encode my wallet's public key into a QR code, and import it into my online Bitcoin Core, as a watch wallet. Part 5 is very important. I will restart Tails, and restore my Bitcoin wallet from the backups. In part 6, I will receive Bitcoin, and then spend it. With the aid of PSBT files encoded into QR codes, the online Bitcoin Core will create and broadcast the transaction. But the signing will happen offline. And finally, in part 7, I will show you how to update Bitcoin Core securely. Let's begin. I'm booting Tails from my online computer. Create persistent storage. Provide a password to unlock the persistent storage. Disable all additional features. And restart. Unlock your persistent storage, and connect to the internet. I'll get the Bitcoin Core binaries from bitcoincore.org. Get the latest release, and the digital signature files. I'll get the signing key's fingerprints from Bitcoin's GitHub. The key's text file is missing from its usual location in the master branch. This might be due to a core developer's PGP keys being compromised recently. I'll get the file from an earlier date. It won't make that much of a difference. Copy the link to this file, and download it. If you run this command, you will fetch all keys included in the file. Now I can do all the verification. Looks good. Everything is okay. So I will copy the Bitcoin tar file into my persistent storage. And shut down. This tells Bootable USB drive will never connect to another online device again. Now I am booting Tails from my offline computer. Unlock the persistent storage. And change the password. It is a good rule of thumb to assume that anything you've typed on the keyboard of an online device is compromised. Now it's time to create a Bitcoin wallet. A wallet that needs to be encrypted with a strong passphrase. A cool way of doing this in Tails is to generate a 12-word mnemonic seed phrase in Electrum, and use that as your strong memorable passphrase. I will write it into a file, for now. To run Bitcoin Core, you can expand the tar file right here in your persistent storage, or do it elsewhere in the system. Your choice. Go to the bin directory, and run Bitcoin Qt. If you get this error, type the following command, and try again. File. Create wallet. Name your wallet, and encrypt it. Make sure it is a descriptor wallet. Great! Now I have private keys, generated offline by Bitcoin Core Wallet. Now save your wallet, in your persistent storage. Now it's time to make a few backups of my wallet. The easiest way to accomplish this, is to store your wallet file into an industrial micro SD card. Make a few of these, and distribute them geographically. Something you should know about these encrypted descriptor wallet files, is that anyone with access to it, will be able to see your public key. If that's an issue for you, you can encrypt the file, or you can create an encrypted volume in the micro SD card. Now let's create a more tangible backup of the wallet. We can do this, by encoding the master private key, into a QR code that can be drawn in a piece of paper. Open the console. And unlock the wallet with the command, wallet passphrase. Followed by the passphrase, and a timeout in seconds. Now type list descriptors, true. And there's the master private key of my wallet. If I go ahead and make a hard copy of this QR code, anyone with access to it would be able to sweep all my Bitcoin in seconds. That's why I am going to encrypt my private key with my wallet passphrase. So anyone accessing my backups, be it a micro SD card or a physical QR code, will not be able to do much without also knowing my strong passphrase. I'll print my passphrase to screen to have it handy. And I will encrypt my private key with a cipher. This is a bigger output, but the gains in security far outweigh the inconvenience of having to draw a bigger QR code. Speaking of which, do yourself a favor and get rid of the first and last lines before encoding this into a QR code. It will be better if you make an image file out of it. A file that you can open in the GUI, view in full screen, and adapt to your specific screen and desired backup size. This is a way of doing it. Get a translucent sheet, cut it to the size of your screen, and tape it. Any plastic page protector will do. This is 5 minutes in. The whole thing took half an hour. When you're done, test it. Let's see if I can scan mine. It works. Now I'll try to get my private key from it. There it is, my master private key restored from my hand-drawn QR code. To create a watch wallet on my online Bitcoin core, I need the master public key of my wallet. Type list descriptors. Here's my pub key. But I will need more than this. I am interested in 2 descriptors. Look for those with this derivation path. The first one is for external receiving addresses. The second one is for internal change addresses. So copy these descriptor fields into text files. I will encode these files into QR codes, so I can scan them from my online PC. I will leave this computer running, and move to my online synced Bitcoin core. This is a fresh Linux install, with only the necessary software to run a Bitcoin core full node over Tor and I2P. Let's start by creating a blank descriptor wallet without private keys. Open the console. I will use this file as a template for importing the descriptors into my watch wallet. Notice that we need the descriptors and a timestamp. For being able to scan the descriptor QR codes, install ZBar Tools and run the command zbarcam. with the raw and no display options. Now move to your offline device, and open the first descriptor QR code. Scan it with the online PC's webcam. And now the second descriptor. Show the QR code. And scan it. Press Ctrl+C to exit. The timestamp refers to a Unix timestamp. Basically it is the date, and therefore, the block height, from which Bitcoin Core will rescan the blockchain to look for transactions pertaining to your wallet. So if this is a new wallet, you can just use the current Unix timestamp, which is what I'm about to do. But if you're importing a wallet with transactions in it, it is useful to know roughly the date of the first transaction, if you want to avoid rescanning the whole blockchain. For getting the current Unix timestamp, use the command date. The watch wallet is ready. I should be able to generate receiving addresses. It works. But if I want to make sure that this address belongs to me, I need to go where the master private key is. Remember this address. Same address. You can do this with any given address. In the console, with the command getdescriptorinfo. This is the first receiving address of my wallet. Please check your addresses before receiving Bitcoin. Before I start transacting with Bitcoin, I will make sure that all my backups work. So, restart the offline PC, and let's go through all of them. I'll start with the file I keep on my persistent storage. Done. This wallet is ready to sign transactions. Now I will manually delete the Bitcoin data directory, and move to the next backup, which is the wallet file that I copied into micro SD cards. Same procedure. As you can see, restoring Bitcoin Core wallets from their DAT files is extremely easy. Now let's move on to restoring our wallet from the master private key QR code. Create a new blank descriptor wallet. As with the watch wallet, I need to import two descriptors for the receiving and change addresses. I will use QR codes to import a template that will help me write the console commands. You can save this text file in your persistent storage, as a template for restoring your backup from the QR code. So here I go. In the descriptor fields I need the master private key, and a checksum. And I also need a timestamp. I will get the private key first. Scanning, and decrypting the QR code. The wallet passphrase is still on a file in my persistent storage. I will eventually remove it and write it down on paper backups, when I make sure that my setup is solid. Here's my master private key. To get the checksum, I will use a console command that requires the whole descriptor as its argument. For clarity's sake, let me write both descriptors in 2 new lines and fill the private key field. I'll get each descriptor's checksum with the command getdescriptorinfo. I got them. I'll use the real timestamp of my wallet, but since this is an offline and unsynced signing device, it doesn't really matter. I have everything I need. Now paste these 2 commands in your console. Wallet restored. Notice that you're missing your HD seed. That's because your extended private key is derived from it, and not the other way around. Don't worry. You will still be able to sign transactions. It's time to test my setup. I will restore my wallet here in the offline signing PC, and move to my online computer. I'm sending some Bitcoin to this address, right now. From a mobile Bitcoin wallet. My node just picked it up from my mempool. I'll go away for a few minutes and wait for confirmation. The transaction is already confirmed. Now I will spend Bitcoin. I already have a Bitcoin address on my clipboard. I will send all my Bitcoin. And I am happy with 1 Satoshi per byte mining fee. Create unsigned. Please check that everything is okay. The unsigned PSBT transaction is copied into your clipboard. I will encode it into a QR code. Depending on the size and resolution of your screen, it might be useful to make a file out of it. Now I'll move to my offline computer, where I'll scan the unsigned PSBT QR code. Copy it into your clipboard. And in Bitcoin Core Wallet, go to File. Load PSBT from clipboard. Please check again: destination address, amount to spend, and mining fee. If everything is okay, sign the transaction by typing the passphrase. The transaction has been signed. Now copy the signed PSBT file into your clipboard, and encode it into a QR code that you can scan from your online PC. Copy it. And in Bitcoin Core, go to File. Load PSBT from clipboard. Broadcast the transaction into the Bitcoin network. There it is. Waiting to be confirmed. I'll go away for a few minutes. Confirmed. Now that everything has been thoroughly tested, I'm ready to delete the password text file and QR code image file from my persistent storage. I will rely on my initial thesis. My Tails USB bootable USB drive will hold my encrypted Bitcoin wallet. And I will keep geographically distributed backups of my wallet file itself, the encrypted master private key, and the wallet passphrase. Depending on your situation, and the way you interact with this setup, you could also commit the wallet passphrase to memory. That's for you to decide. I promised to say something about how to update Bitcoin Core securely. Well, it's rather simple. Whenever there's an update, follow the same procedure as I did on part 1, downloading and verifying the binaries from the online computer. Copy the verified new release into a brand new disposable SD card, the cheapest you can find. Boot Tails from your offline PC and replace the Bitcoin Core tar file. Then physically destroy the SD card. Until next time.